Frank flying for Didier also, who took the aircraft half a day out of the tremendous flight test program. Thanks all for this tremendous flight. We really appreciate it. And also we appreciate that you take now another 1 hour with us to guide us through the latest development in the flight test program, A350 flight test program, A320 Neo flight test program. And I'm very pleased to have here now on stage Fernando Alonso. He is Senior Vice President Flight and Integration Test. Patrick Touché, he is Head of Development Flight Test. And Sandra Boer-Schäfer, she is Project Flight Test Engineer for the A320 Neo. And I pass on to you, Fernando.
So, thanks very much. I hope you enjoyed the flight. Do excuse us if something did not work well, but our job is not to carry passengers around the sky. Our job is to test airplanes, so if something in the service was not good, do bear with us and apologize for that. And also, because we've been improvising since this morning, the presentations today were supposed to be starting in the morning, then we would have had you visiting the airplane. So maybe they're not completely adapted to the fact and your state of mind after having had the experience of flying on the airplane, but we will try to adapt and to pass you the messages and tell you what we wanted to tell you in a different environment. So I just want to make a quick introduction. Before that, I say, no, just to catch up on the flight. I hope you appreciate the experience. I think, as I said at the beginning this morning, that an experience is worth 1,000 images or 1,000 words. So I really think that whatever we're going to be telling you about how good the airplane is, how proud we are about the airplane, how quiet the cabin is, how good the lighting is, how everything, nothing is better, nothing will substitute the fact that you have actually experienced it yourself. So I hope, as I say, I think that will reinforce the message that we are trying to pass to you of our optimism on the way the program is going. Quick word about flight testing and how it is evolving. Next. We, the Flight Test Organization, we consider that we have a mission which is number one, safety. Safety not only of the way we go about doing things, so safety in the way we do flight tests, but also safety in the passengers. All of us bear in mind the fact that whatever we do, we always have in mind the fact that this airplane is going to be flown by pilots, it's going to be carrying passengers, and we like to think that, you know, we want to treat all the passengers taking into account their safety environment. Of course, second to safety is customer satisfaction. We're building this not just to have fun ourselves, which we do have fun, but it's also to please what the customers are expecting and actually make sure that we deliver to them an airplane that fulfills their expectations. And third, but not least, reducing lead times. And I will touch on that at the very end. Over the years, we have seen a continuous deterioration in the time it takes to develop and to certify an airplane. At the time of when I joined the company back in the 80s, it would take us about 1 year to certify an airplane, 1 year of flight testing, and things have been degraded. And not only in this part of the Atlantic, on the other side of the Atlantic, things have been degrading, and it takes us longer, and it used to take us longer and longer to develop and certify an airplane. So was one of the objectives of the new organization, which I will be talking to you about, and which has been running the A350 development activity, to try and reverse that curve in ever-increasing durations on the development of airplanes, to try to see how can we reduce the duration, the time span it takes to certify and deliver an airplane with same or better safety standards and same or better maturity at entry into service. So reducing lead time has been one of the driving factors of what we have been doing in preparation and on the flight test of the A350. So what do we do? In a way, we're like a little airline. We have a number of airplanes which we do major development testing. So in 2014, we have two major programs going on. We have the A350, which we'll be talking about. We will also be starting to fly the A320 Neo with Pratt engines later this year. And we have continuous development on the different programs. So we have long-range airplanes, A330 and A340 in our fleet. We have A320, which you have seen turning around over the last 2 days, doing development and preparation for the NEO. And we have an A380. We also have A400M development airplanes. And these airplanes are with us because there's always modifications, upgrades to the airplanes in service, which need to be tested and validated before we deliver them to the customer. All in all, that means that our team handles 22 development airplanes this year. We'll be handling 22 development airplanes this year. As we move on next year, we will be handling 16 airplanes. So the A350-900 will have completed its initial development. It will be continuous development. We will have the major development of the A319, 21 and 19 NEO, bringing our development fleet to 16 airplanes. And then in 2016, we'll come up to 19 development airplanes. On top of that, so we are a little airline with anywhere between 15 and 22 airplanes flying every day. But on top of that, our team does the delivery of all the airplanes Airbus delivers. So we have teams who do the delivery of all the airplanes produced, both in Toulouse, in Hamburg, in Tianjin, and equally in Mobile from 2016. So, as you see, quite a significant amount of activity. And how do we do that? The way we do that is that in the past, so quite extensive activity. In the past, testing in Airbus was split between testing done by the design office and testing done by the flight test team. And we have been regularly seeing a number of issues coming up during the flight test campaign, which unfortunately the flight test team were not really aware, but those items had been identified previously during ground testing by the design office. So there were two separate teams, one which was ground testing team, the other one was flight testing team. And in 2007, we decided to merge all of that into one single team, which is called the Test and Integration Center, Test Center, which I have the honor and privilege of leading. And the purpose of that reorganization was to bring together all the people doing testing, and more important than that, we wanted to involve the people doing flight tests, the pilots, the flight test engineers doing flight tests, try to involve them as much as possible in the testing upstream, so they could be assessing the behavior of the systems on the ground with an eye, with the eye of a pilot. So we wanted to give to this new team a very customer-focused approach. We wanted to be able to treat the airplane as if we were the first customer, but from the very beginning, before the airplane ever existed. By the time we only had simulation models, we only had test rigs, we wanted to start testing with a customer-focused approach. So from the flight test point of view, all the activity that you've seen before, we do barely with 43 pilots, with 58 flight test engineers, basically a team of about 100 or 120 people. So I'm very proud of the team. I think it's probably a benchmark in efficiency in the industry. We're a very small team. We voluntarily want to stay small. We want to stay lean. We want to stay reactive to be able to do the type of things that we did today. We improvised yesterday. We said we're doing the flight. We can do it today. So I'm very proud to lead this team of about 120 flight crews. And on top of those 120 flight crews, there's all the activity which sustains the flying, which is the ground testing activity, which I mentioned before. So all that activity testing is now one single team. There's continuity in the testing, so we are involved in the testing at our suppliers' facilities. Then when the equipment reaches Toulouse, we do testing in the equipment in Toulouse, we do integration testing in the labs, and then the same teams that have done all that testing upstream actually go and test the airplane. So the objective of that was safety, customer satisfaction, and reduction of lead time. And I think what we're going to be showing you today is that we believe, we're optimistic that we think we're getting the results that we were expecting of this change of attitude and change of organization. How do we do testing? In fact, the fundamentals of testing airplanes have been there from day one. And I always like this picture, which shows how people used to do static testing on wings until rupture back in the 1930s. And of course, in the 1930s, today we do them like you see there on the right-hand side on the A350. We have the airplane and we pull the wings up until they break. In the past, they didn't have the capability of pulling the wings up, so what did? They flopped the wing over, and then they load it with cement sacks. And that's the things we're doing. The best message there is that the fundamentals and the fundamentals of testing airplanes and what is at the basis of the level of safety that today air transport is showing is that people long time ago already identified what were the critical areas and what were the critical tests that needed to be done. So if air transport is here where it is today with the level of safety is because way back then people had identified that identifying the structural capability of the airplanes was important. Of course, today we're also it's just as important. However, we have different tools, different ways of doing things, but the fundamentals of testing airplanes remain the same. Another evolution is this one. Also, our predecessors back in the 1950s identified things which were called fatigue. One of the reasons of fatigue was what we called acoustic fatigue. So how does the jet blast noise excite the fuselage, and how can that generate fatigue? So on the left-hand side, you have the way those microphones were installed on the Caravelle skin, and this is the way they're installed on the A350 skin. So again, the fundamentals of testing remain the same. However, we're using technology continuously in order to be more accurate, to be more agile, to have more data, more information. Another very good example is one of the things that engineers love most is to see how the wing moves over the wings. So in the past we used to install what we called pressure belts, which are strips of metal with little holes which you would stick on the upper surface or lower surface of the wing, and each one of those little holes had a little tube, and you would be measuring the static pressure, the pressure on the upper surface of the wing. That was a very complicated installation, very heavy installation, but it allowed the aerodynamicists to have a feel or have actual measurements of how the air was going over the wings. Today on the A350 we have developed a technology where we install pressure sensors on literally a Scotch tape. We install those pressure sensors on a Scotch tape. We connect all those sensors to one wire. We put that Scotch tape wherever we want on the airplane, and that wire brings it to the instrumentation, and we can therefore measure the pressure, see the pressure distributions anywhere on the airplane. And to look at, as a comparison, before we used to have those holes were like the size of a €2 coin, and look at today by comparison the pressure sensors that we're installing. All that is extremely small, extremely compact. So the fundamentals of testing remain the same. However, we're using technology on a continuous basis in order to be able to do those fundamental tests with more modern technology. The result of that is that the amount of data that we're recording on every single flight has grown exponentially. So just as an order of magnitude, I've given you some numbers there. On the A320, we would record something like 12,000 parameters. On the A380, we recorded something like 320,000 parameters, and when we said that, we said, well, it's a 380, it's first double-decker, it's a big airplane, it's normal that it's so big. Guess what? When the A350 comes, we record more than double. So we're recording 670,000 parameters. So we're getting massive amount of data, which create problems of how to store that data, how to retrieve that data. So we have been developing a big data project, which using the latest technology available from the IT business in order to be able to store, retrieve, and use that data. Because if we're recording the data, it's just for the fun of recording the data. It's for the interest of identifying how the airplane works, how the systems work, and all that for the purpose of maturity and customer satisfaction. Okay, specifically applied to the A350, I think with some of you have been talking during the flight. What has changed is that the fact that the same team that is actually flying the airplane have been involved in doing all the systems integration testing before. So we have had a very large and comprehensive set of ground equipment, tests and simulators. We have an Ironbird, we have simulators, we have landing gear rigs, flaps rig. When I talk about the landing gear rig, what it is the complete installation of the landing gear and the braking system on the airplane. We have it on the ground. The same hardware, same equipment, so we're able to test everything on the ground before it's actually installed on the airplane. The purpose is always to try to test as much as possible upstream. The later you discover problems, the more difficult it is to correct them, and the more expensive it is to correct them. So we're trying to push to test as much as possible upstream, to discover the problems as early as possible, and to be able to have the time to correct them as quickly as possible, with the objective of being able to reduce the amount of flight testing that we do on the actual airplanes to only that testing that where we actually need to have the airplane in flight to see the behavior. You need to fly to measure the performance of the airplane. You need to fly to measure the climb performance of the airplane. But everything that has to do with systems, there's no reason why all that could not be tested in the ground. So a huge effort and a huge investment has been done by us in this new organization in order to do to give ourselves all those ground testing facilities with the objective of trying to improve the maturity of the airplane. We believe we're there. Patrick will give you some words of where we are. But the optimist part of me is telling me that given the flying rates that we're getting on this airplane and the level of maturity that we're seeing on the systems, I think all this investment and all this new attitude about testing, of being customer-minded from day one, even from the time of the initial testing at the suppliers, is really starting to pay off. And we think our bet is right. There is the chart that I was talking to you at the beginning. With time, the duration of the development campaign of a new airplane went from anywhere between 12 months on the A380. We did 20 months, and then we said, if we continue like that, and people on the other manufacturers are also seeing this trend, this ever increasing trend of increasing duration, we said, where are we going to go? We cannot afford to launch an airplane and spend 2 years, 3 years doing flight tests. So we said we have to do all of this in order to revert that tendency. Our objective was to certify the A350 in 14 months. I touch wood. We're not very far. We're not very far, and I think in 2 months we will be there, and we will have reversed the tendency. So I'm going to anticipate some of the questions that you may guys will be asking later. Will we ever reach zero flight test time to certify a new airplane? The answer is certainly not in my lifespan. I still believe that we will have the need to flight test airplanes. I definitely also believe that there's a possibility of improvement, and I think the innovations that we have done in the way we do testing in Airbus for the A350 shows us a trend, and I think we can continue improving the time it takes us to test the airplanes. Let's wait until we finish the A350. Let's wait until the A350 goes into service. And if what we're seeing today is confirmed, that is telling us that we're doing the right thing, and we will continue improving that. So, having said that, now Patrick will talk to you about where we are on the A350. Sandra will explain what the plans are for the A single aisle Neo, which is basically around the same, applying the same principles as of the A350. And then at the end we can have a session of questions and answers with Peter and Frankie. You can join us later if you have any other questions on either of the presentations or on the flight itself. So, Patrick.
Okay, so normally there's a movie now, which should be launched. So, sorry we're not able to update the movie with you on board, but we'll do it very shortly. So the movie is expressing the emotion. Now you will have to sustain the speech. Where do we stand now about the flight hours? Fernando was saying we are flying a lot. I can confirm we have flown a lot. By the way, if you look at this number, this is not the actual number. This is the one as 2nd of June. Today we are more around 2,000 flight hours. Not today, but next week, pretty sure we'll be at 2,000 flight hours. And you have the repartition, of course. We are flying a lot with MSN 1 and MSN 3. MSN 2 and MSN 4, by the way, joined the fleet the same day. They flew together on the 26th of February. This is the first time we are having two prototypes flying the same day, so it was the first for Airbus. And you see that now we are catching with flight hours on those two aircraft also. So I imagine you know this chart because it was presented last year. This is the way we developed an aircraft. So we have a flight test campaign which is divided in 4 phases. Essentially we could say 2. First we develop, and when we are ready, we present the aircraft for the certification test to the airworthiness authorities. And we have a plan, roughly, to say exactly when we would like to perform such a test, like the high altitude campaign or the cold campaign, which can only happen when it's cold, so preferably in January, and all other tests. If we look at what we have achieved since the beginning of the year, I would first raise the high altitude campaign, where we have been in Bolivia, Cochabamba and La Paz. It was quite pretty emotional also, because it was the first time that the aircraft was going away. So it was the first time the aircraft was leaving Toulouse to another destination, which was in Latin America. Then you have seen some pictures in the movie of those tests, which are very important for us. They are certification tests, by the way. This is the external noise test campaign that we performed in Morón, in Spain, where we are performing approaches to represent the landing and the takeoff. And we measure the noise, knowing we have to answer to some certification requirements. And it went pretty well, and we are exactly at the level we wanted, so good news. Fernando was speaking about customers. Yes, we are customer-minded, and we are also so proud of the aircraft that we are happy to show the aircraft as soon as we can to customers. So we had the cabin unveiling in Hamburg, where we had more of 100 customers during that time, plus many people from the media and the press. So that was the first event. But then I should also mention that we have flown with customer pilots. So we have flown when we were in Doha with 2 Qatari pilots, 2 pilots from Qatar Airways, and we have flown also when we were in Singapore with 2 Singapore pilots. So, and by the way, if you want to know the feedback about those 2 flights with customers, with airline pilots, the feedback was really, really positive, and we were quite impressed ourselves, by the way, because we were entering in the cockpit. Peter was doing a brief for 30 minutes, and then we were taking off with the guys. And they were feeling at home, because they were knowing also Airbus aircraft. So, but very quickly, for us, it was a non-event. They were flying as they have flown the aircraft since the beginning with us. Hot fuel. Why do I show this chart? It's just to tell you that sometimes we have to be agile. Normally, to do those tests before, in the past, we were going to Filton. And there we had the hot fuel, which was warmed up by the ground people. Unfortunately, Filton is an airfield which is closed now. So we had to go elsewhere, and what we decided is to go close to Filton, in an area which is called Campbell, 50 miles away from Filton, and we transported the hot fuel there to do our test. So it's never given. Sometimes you expect to do as you have done before, but it's not possible, so you have to find a way out. And this is why I'm presenting this slide. High energy rejected takeoff. This is a critical test for the aircraft. There are two tests, by the way. Normally you do what is important is the maximum energy rejected takeoff for the certification at the end of the maximum performance that you can bring to the aircraft during the takeoff. But as it is a critical one, we keep that one for the last one, for the end of the campaign. Nevertheless, we need to certify an aircraft flight manual. That's why, since the 380, we have decided to go a step below, which is close to 85-90% of the maximum energy you could have in the brakes. And this is called the high energy rejected takeoff, which was performed in Toulouse it was end of April, with very good results. And by the way, we are very proud because we are working with models, and you target an energy, and you're supposed to have there, for the weight you have, a certain distance. We were close to 5 meters to what was saying the model. So very good news for us, because then you can update the model, but you know also that when you are targeting the max energy rejected takeoff, you know how to target exactly the distance that you would need to perform the test. So you have also seen the water trough test, or I call it the swimming pool test, because this is a small swimming pool of 100 meters. This is an impressive test when you see it, when you see the pictures, when you see the movies. It can be also a tricky test for the aircraft. I can tell you, we had some bad experience on the 380 in the past, because it's not about the fact that the spread, the way the splash of the water is spread all over the wing. That's not an issue. It's the way the other part of the aircraft would react. And on the 380, for example, we had some issues with the hydraulic pipes, which were fitted on the landing gear, and we had to reshuffle the way you build the aircraft for those pipes. So here I can tell you we've done the test without any issue, which was really good news, because when you go there, you don't know what would happen. And here again, I'm happy to say, so far, good news. You've heard about McKinley. McKinley is a climatic chamber, which is in Florida, which was used, by the way, by 77. We've been there not for certification purposes. We've been there for maturity reasons, because we are customer-minded, as we told you, and we need to be sure that the aircraft will behave properly in all conditions. Should it be hot? Should it be cold? So we've been there for 2 weeks in this climatic chamber. We have tested the aircraft on ground, of course it's on ground, at plus 30 degrees and 90% of humidity, which is a lot of humidity, and also in dry air condition at 45 degrees. And then we went in the cold conditions, 30 degrees, minus 30 degrees first, and then minus 40 degrees, where we started the engines. You have seen the pictures. You have seen the pictures with the ice all over the landing gear. I can tell you that day we started the engine pretty well. So, when you fly, you have two possibilities. You can have on the upper part of the picture those nice dummies. They are very good because they are silent shoes. They are quiet. They don't move. So it's for us it's cool. And that's to test the air conditioning, by the way, because those dummies are heated like a body, like us, at 37 degrees. And you check that you are able to have the good airflow for the temperature all over the cabin. That's the first part of the test. Then we are much more happy when we have passengers. Of course they are moving, but they see some emotions, which is not the case of the dummy. And we have done last week the 2 first flights with the aircraft full of passengers. So it was one flight in day conditions for 7 hours, Toulouse, with 250 people on board. And a cabin crew from Air France. And then we had the day after, over the night, another test for 12 hours. Just to say that we would like to test the aircraft, okay, in day conditions, that could happen, but also with passengers sleeping and in night conditions for 12 hours. There we had a cabin crew from Lufthansa. To rebound on what you were saying, Fernando, this flight test campaign was heavily prepared during 5 years, 6 years, I would say. From the beginning, it was important to decide how many aircraft should we need. 4, 5. We went through the idea that 5 aircraft was important, 2 with a cabin, 3 without a cabin. How you would instrument, you would have which flight test instrumentation you would have for all those aircraft, which means what you would do on all those aircraft. This has been really prepared for the flight test, of course, for the ground test also. And we have done a lot on the zero test means that Fernando was speaking about. For example, this is the first time that we have a cabin zero. So that's a new rig that was built particularly, specifically for this aircraft in order to be able to test upstream the cabin and not to wait for MSN2 to start the cabin test. I was saying also that we have to be agile. Every day we have to optimize the flight test planning. Every day, not to say every 10 minutes or every hour. Because you are relying on many other people than us. First, when we are flying, it depends on the traffic control. Do they take us or not? Sometimes they cannot. Then, some tests are meteo pending. I cannot go for the natural icing test that you have seen in summer here in Toulouse. So you have to find when you will do the test. Then you have the configuration of the aircraft. When we do a test, it's to bring back some results. So I need the flight test instrumentation ready for that. So we are upgrading the aircraft every day just to be sure that we are able to bring back the result, to analyze the result, and then to show them to the authorities. So I can tell you, it's a constant work that we are doing with the team. And by the way, you have seen that MSN2 has left because he's supposed to be prepared for another flight this afternoon. No waste of time. We are always struggling to keep the time running. And this is why we have to be agile. On the results, we have a lot of positive results thanks to the validation and the verification which has been performed upstream. I was speaking about the fact that we have many tests thanks to ground test rigs. Today, we are able to, we are finding still some issues in the aircraft. But if you compare to what we have found with the previous program, we are far better. Why? It's just because those findings which were coming during the flight test campaign have been seen before and corrected before, thanks to the test that has been performed not only in our facilities but also in the supplier facilities. Last but not least, I'd like to say that we have achieved a flying rate for a flight test campaign that has never been done in Airbus. We have been able to go for sometimes more than 100 flight hours per month. Today, in average, we are at 80 flight hours per month per aircraft, which I can tell you it's quite a lot. That's why today we are at close to 2,000 flight hours. Without that, I would not be able to say that yes, Fernando, we can be optimized on the fact that we certify on time. Yes, we can do it because we have been able to sustain a higher rate of flying hours. But it's not finished. It's not finished. We still have some activities that are running now. As I'm speaking now, MSN3 has landed in Middle East for a hot weather campaign. The aircraft was supposed to leave tomorrow morning. By the way, again an example of agility. We had an issue with some parameters, FTI, flight test instrumentation, and I wanted to have the good parameters working properly. So we said we first repair and we go in during the night. So yesterday they took off. I think it was close to 11 o'clock, and they are now working already in Middle East in Al Ain. So that's some important certification tests that are being performed there in these hot conditions, where it's about 45 degrees right now. I have, of course, I was speaking about the maximum energy rejected takeoff, which would come later in the summer. I would like to highlight the fact that what is important for us now is to get MSN5. So we will get MSN5 flying very soon, and then we will concentrate the activity of the certification, or the certification activities on this aircraft, with, at the end, the so-called route proving that you may have heard about already. It's called route proving, or it's called functional and reliability testing. So we have to show there that the aircraft is functional, is reliable, and that it can operate the aircraft as if it was an airline, as if it was operated by an airline. So we are going to fly all over the world. Don't look at exactly the traces that are shown there. These ones are the ones which were used for the 380. But we are preparing right now the plan where we go. It will last close to 3 weeks, and we will go close to 200 flight hours, knowing that at the end we would clock 300 flight hours for this exercise. But we have 3 weeks dedicated to that over the summer. I was speaking about airline, customer. I just would like to highlight also that we are trying to work sometimes like an airline. We have what we call an airline one office, where we are tracking all our aircraft when they are flying, just to check how they behave. And when we come back, we have already people on the ground. We have checked, okay, this is a failure which is normal, because this is exactly the purpose of what we have done. We were going on purpose in a failure cases. Sometimes we have some issues, and we have to look at why we had those issues reported on the post-flight report. But they have it before we land. And the guys are already analyzing exactly as if you were an airline, what happened during the flight. And this is very important for us, because this is helping to sustain the flight hours rate that I was speaking about. I think I'm finished now, so of course we optimize, we are optimists. I would say that we must remain humble, and this is the purpose of any flight test activities and flight test crew, to remain humble, because you never know what can happen. So today we are pretty optimistic, but having said that, we touch wood, and we hope we will certify still on time without any issue during the next two months. So I hand it over now to Sandra for the question. It will come after. Sandra will speak about the NEO.
So unfortunately, I have no nice movie, no pictures to show you. As you know, the NEO has not flown now. But I'll try to walk you through on what we have planned to certify all the NEO types in quite a short period of time. So as you know, when we speak about NEO, we will have an A319, an A320 and an A321. And we offer 2 types of engines, the Pratt & Whitney 1000J GM and Pratt & Whitney 1100, and the CFM LEAP 1A. The aerodynamic baseline of the NEO is pretty much known. It's very close to the Sharklet, and to that respect, the Sharklet certification campaign really paved the way for the NEO flight test campaign. So we have an aerodynamic which is very, very close to what we have on the Sharklet. We have new engines, so it sounds quite easy. It's not exactly as easy, because we'll have to meet all 2015 certification requirements, which have quite changed since we first certified the A320. And as you all know, we have a very challenging performance program, so not only for high-speed performance, where we will have 15% less fuel burn, but also takeoff performances, climb performances, landing performances. You have heard yesterday that our airplane, due to the new nacelle and engines, will be roughly 1.6 tons heavier than current airplanes, but we still want to meet the same landing and takeoff performances. So we had to adjust to all of that, and fly-by-wire technique was a huge benefit to that, to be able to change laws and adapt to those new requirements and performance targets. During the Sharklet flight test campaign, we already knew that we will fly NEO aircrafts, and we also take the advantage of this flight test campaign to do testings which helped us to assess future modifications of the NEO to try to be proactive. So as I said, we have to certify 6 aircraft types, 2 A319, 2 A320 and 2 A321. We can't afford having 5 aircrafts per type as the A350 has. There's no need for it anyway, it's not a brand new airplane, but we still have to go through a huge amount of tests required for certification and required to demonstrate the performance. And we try to optimize it, really building on the commonality of our airplanes, building on the family concept and trying to reduce as much as we could the flight test aircraft and to go through this certification as efficiently as possible. So if we start with the A320, this was the first one to fly. There we'll have the aircraft certification, but also the engine development and certification. So in order to do that, you will see that I make no differentiation between Pratt and CFM, because basically it's the same way we'll operate with both. We'll have 2 A320 Pratt aircrafts and 2 A320 CFM aircrafts. The first one to fly will be a heavy instrumented aircraft, and the second one a lighter instrumented aircraft. Thanks to that, we are capable either of flying with the first one heavy instrumented aircraft in the normal, but also in the peripheral domain. And the other one, being a lighter aircraft, is more representative of what we'll show our customers. It will be more representative for noise measurements, for example. So we really try to match between those two airplanes with their specificity, each gross weight, flight test instrumentation, to put the right test on the right aircraft. The way we have sequenced the test is as what was done for the 350. We'll start with the initial development or the aircraft flight manual testing, then we'll move to a period of certification, and you see there's a huge time period dedicated to maturity. We have a huge ramp up on the 320 NEO family, so we need to be at a very mature level. We need to be equivalent to the reliability our customers have today, so it's extremely important for us that we do ahead of time maintenance procedures, operational test cards, and so on, to really have an airplane which is mature and equivalent to what our customers know today. So if we go a bit more into detail of those flight test campaigns, the first one, as I said, heavily instrumented, so it's really dedicated to flight physics, opening up the flight envelope, as I said, going to the peripheral flight envelope, doing all the performance, all the high-speed performance, all the low-speed performance, and we'll do the majority of engine testing there. What we have chosen is to certify all the engine tests on the 320, which means that we'll not only use the 320 rating, but also going up to the A321 rating, so that all engine tests basically will have been done on the 320. And there you will find tests very similar to what has been done on the 350, so we'll have to go to the high altitude campaign. We'll also go to cold weather campaign, and we will do a hot campaign as the 350 is currently doing. The second aircraft, as I said, is much closer to what the airline will have. We'll do specific tests like the external noise. We have no intrusive flight test instrumentation on that one. There are no pressure rates, for example, on the engines. The pressure rates are used to have a correct measurements of the thrust of the engines. Though this one is very clean, it has roughly 10 times less instrumentation than the other one, and will be representative of what the airline has, and will measure noise, for example. We'll do all the Autoland campaigns on that aircraft as well, and at the end we'll do everything which is related to ETOPS or functional and reliability to demonstrate that our aircraft is capable of operating normally. And if we move now to the 319 and 321, as I said, engine tests had been done. Normally we have demonstrated everything on the 320 up to the A321 rating and down to the 319 rating. So there we'll only concentrate on the integration of the engines on that particular aircraft and demonstrate the aircraft flight manual and demonstrate that the flight controls are adequate. But for that, we only need one aircraft per type. So we'll have one 319 Pratt & Whitney and one 319 CFM. And equally, we'll have a 321 Pratt and a 321 CFM. And basically, they will do pretty much what I said from the 320 campaign, but for the detailed engine testing. There are some differences, however, between a 321 and a 320, for example. You might know 319 and 320, they share the same wing, so there are many tests we can read across from one to the other. 321 is a bit specific, and therefore you will see on the 321 test that we have not done on the 319, for example. Like the external noise test, we'll have to repeat it. We have another wing, we have other flap settings, so we'll repeat the external noise testing. And we'll be doing testing on the 321, which are only specific to that one, that the water ingestion test you have just seen. We could demonstrate to the authorities with our model that A319 and 20 are not critical with our new engines. And the size they have. On the 321, it's a bit different, so on that one, we'll go for a specific test for the water through, for example. So you have seen it's quite a challenging campaign. Even if it sounds easy, even if it's only engines putting on an airplane, which we pretty much know because it's close to the sharklet. As I told you, the certification requirements have changed. We want to meet the performance, and we are conscious that due to the ramp up and due to the quality we want to deliver to our customers, we want to have the best aircraft possible immediately. So we took the opportunity of having an A320 in our flight test department and an A321 to do many upfront testing. So we have already done about 250 flight test hours with hardwares and softwares for the flight control laws, for example, which are the ones we will be using on the NEO. We have put them on the traditional aircraft and tested them. You might have noticed yesterday that the A320 was flying low in front of you quite a few times. They were doing preparation for the NEO, starting to measure the performances that takeoff will have at the NEO with the modification we have already introduced on that, on those flight control laws. It's not only us, it's also the propulsion system which is being tested. Pratt & Whitney, as well as CFM, have or will have a flight test bed. They are testing many engines at their bench or in flight. We have also tested some specificities. We'll change the aft pylon fairing on the 320, and we took the opportunity to put it for test only on the 380 to have a look at what will be our behavior of the new aft pylon fairing design, we'll have on the NEO. And we have obviously all the tests on the benches, like the thrust reverser test benches at Airbus. So you see, we have prepared quite a lot. Now, what's remaining up to first flight of the A320? You saw yesterday, the aircraft is finished. It has no engines, but it's assembled. That is the first NEO, this NSN 6101, which will fly in September. This is the flight test instrumentation. This one is powered on, contrary to what you saw this morning. So they did the power on, they checked the instrumentation, and it's ready for first flight. The engines, as you know, have arrived at the podding at the UTAS facility, and they will be mounted on the aircraft quite soon. What is remaining also for us will be all the virtual flight test campaign, which we'll conduct over the summer. So basically there, it's a test campaign in the simulator where we simulate all kinds of failures and get ready for the first flight. So we are confident, and we are ready for the first flight in September 2014. Thank you.